Welcome to this Maths Made Easy video on vector calculations. To start with, let's take a look at finding vector magnitudes using Pythagoras' theorem. Now if we just begin with the notation here, let's say we've got the vector A. So the magnitude of vector A is written as A between two bars, okay, like so. And similarly, the magnitude of, say, the vector A to B, like so here, well, the magnitude would be, again, just using this bar notation, like so. Okay, so that represents the magnitude there. Now, if we use this diagram here, we can help visualize what the magnitude represents. Now, we notice here that I and j components form a right angle triangle. Okay, so the I and j components of a vector form a right angle triangle. And remember, with a right angle triangle, we can use Pythagoras' theorem and basic trigonometry. So we can use Pythagoras' theorem here to find the magnitude, which represents the length of the vector. So using this example here, if we want to find the magnitude of vector A, that's just a simple application of Pythagoras' theorem. So here, the magnitude of A is simply equal to the square root of 4 squared, so 4 squared there, plus 5 squared. Okay, and if we evaluate this here, that simply gives us the square root of 41 there. Okay. Now, sometimes you may be required to find a unit vector in the direction of a particular vector. And we can find that by using the following formula. So let's say we want a unit vector. So we want a unit vector in the direction of A. Okay. So we want a unit vector in the direction of A. Well, in that case, the vector A here is simply equal to A divided by the magnitude here of A, okay? Like so. And as stated, in position vectors, a unit vector has a magnitude of 1. So let's take a look at a brief example here. So if we clear our previous work in here, let's take a look at a brief example then. So let's say we want to find the unit vector in the direction of m equals minus 3i plus 6j. Okay. Well, the first thing we need to do here is just find the magnitude of m. So the magnitude of m, remember this is just a simple application of Pythagoras' theorem. So this is the square root of minus 3 squared plus 6 squared. Okay. And if we evaluate this here, this is equal to the square root of 9 plus 36, which is equal to the square root of 45, which we can write as the square root of 9 times the square root of 5. And clearly the square root of 9 is equal to 3. So we write that as 3 root 5. Okay. So therefore, the unit vector in the direction of m is given as m divided by the magnitude of m. Okay. So m divided by the magnitude of m. So in that case, this is simply going to be m divided by the magnitude, which we just found to be 3 root 5. Okay, so 3 root 5. And in that case, we could just simply write this as 1 over 3 root 5 times by our vector here of m. Okay, so in that case, we could write that as minus 3i plus 6j there. Okay, and that gives us the solution there to our example. And that gives us everything we need for finding vector magnitudes using Pythagoras' theorem. Let's take a look now at resolving vectors into component form. Well, when calculating with vectors, it's often easier to work with them when they are separated into I and j vectors. This allows you to work with one component at a time. So splitting a vector into components is called resolving the vector, and this can be done by using trigonometry and Pythagoras' theorem. So let's take a look at this example here. Now, what we want to do here is find the horizontal, the I component, and the vertical j components of this object's velocity v. So what I want to do here first to help would be to draw a diagram. So if we draw a diagram here just to represent this problem, what we've got here is this diagram. And notice what we've got here now is just a right angle triangle, and remember with a right angle triangle we can apply basic trigonometry. So what we want to solve here is x and y. That's what we're looking to find here. Well, simply applying basic trigonometry then, what we can see is cos of 38 degrees is simply equal to x over 11. Okay? And in that case, if we want x here, we just times by 11. Okay, so therefore x is equal to 11 cos 38 degrees. Okay? And we'd repeat this now to find y. So in that case, this is going to be sine 38 degrees. That's equal to y over 11. Okay? And again, to find y here, we just multiply through by 11. So y is equal to 11 sine 38. 38 degrees, sorry there. Okay? So in that case then, v is simply equal to 11 cos 38 degrees. And that's our I component there. So that's our I component plus 11 sine 38 degrees. And that's our j component there. Okay? And this is in terms of v here, the object's velocity. So that means we're going to have units of meters per second there. Okay? And if we just evaluate this here, this 11 cos 38 degrees, remember, working with degrees here, so just be careful for that. What we find here for v, this is equal to 8.67 I plus 6.77 j there. And again, don't forget our units here. Okay? So that gives us the solution to our example and gives us everything we need there for resolving vectors into component form. Let's move on now to take a look at finding the distance between points using the vector's magnitude. Now when you're calculating the distance between 2 points, this is usually fairly straightforward. All you need to do is find the vector between them and then calculate its magnitude using Pythagoras' theorem. So if we take a look at this example here, we've been given the position vectors of the points k and l. And what we want to do then is just find the distance between the points k and l, giving our answer to 2 decimal places. So what we want to do here first is find the vector kl. Okay, so the vector kl here is what we're looking to find. So in that case, the vector kl is simply going to be minus 3i. So minus 3i plus 5j minus the vector here for k. Okay, so minus 6i. We'll put this in brackets just so we don't make any mistakes with our minus signs here. Minus the 2j there. Okay. Well, in that case, we've got minus 3i minus 6i. So that gives us minus 9i. And then we've got plus 5j minus 2j. So that's 5j plus 2j, giving us 7j there. Okay. And finally here, all we need to do then is just simply calculate the magnitude of this vector here. So in that case, we're looking for the magnitude of KL here. And remember, to do that, we just apply Pythagoras' theorem. So this is equal now to the square root of minus 9 squared plus 7 squared. Okay. And what that would give us there is 130, or the square root of 130. And remember, we want our answer to 2 decimal places, so we need to evaluate this and then round it to 2 decimal places. And if we do this correctly, what we get here is 11.40 there, so 2 decimal places. Okay, so that gives us everything we need there for finding the distance between points using the vector's magnitude. And finally, let's take a look now at using the cosine rule to find the angle between 2 vectors. Now, to find the angle between 2 vectors, say A and B, you can construct a triangle with A and B as 2 of the sides and then calculate the magnitude of the vector AB for the remaining side. And we can then use the cosine rule to find the angle between the 2 vectors. So let's take a look at this example here. All we're simply looking to do is find the angle theta between the vectors OA and OB. And we're going to give our answer to 2 decimal places. Now what would help here is to just do a quick sketch of the problem at hand. And what we'll get here roughly, just to start with, is this vector here. Okay. Now ignore the lengths to start with, we're going to calculate them now. Okay, but just so we can see the problem at hand, this is what we're working with. So the first thing we need to do here is calculate the magnitudes of the vectors OA, OB, and AB. Okay, so to do that here, let's start with the vector OA. So the magnitude of OA here is the square root of 4 squared plus 1 squared. Okay, and in that case what we get here is 16 plus 1, giving us the square root of 17. Okay, so that's where this square root of 17 comes from. Now we calculate the magnitude of the vector OB. And here again, using this now, that's going to be the square root of minus 2 squared plus 5 squared. Okay, and here again, if we do this correctly, that's going to be 4 plus 25, giving us the square root of 29. And we can see that corresponds here to this length here, square root of 29. And finally then, we need to calculate the magnitude of this vector here, AB. So before we can do that, we need to actually work out what AB is. So the vector AB here. Well, to calculate the vector AB, that's simply going to be OB, vector OB, minus the vector OA. If we evaluate that first, that's going to be 4i plus j. Sorry, that's going to be other way around, so that's going to be, we'll just erase that. So if we do this here, so that's going to be the vector OB, so that's minus 2i plus 5j minus 4i plus j there. Okay. So in this case now, minus 2i minus 4i gives us minus 6i, and 5j minus j here will give us plus 4j there. Okay. So here now we need to find the magnitude of this. So this is the vector AB. So therefore, the magnitude of the vector AB simply equal to the square root of minus 6 squared plus 4 squared. Okay, and if we do this correctly here, this is the square root of 36 plus 16, which gives us the square root of 52 there. Square root of 52, which we can express as 2 root 13. Okay, and that's where we get our 2 root 13 from. So finally, what we need to do now is just the cosine rule to find the angle theta. So make note here now of all our lengths, and what we'll do now is calculate the angle theta. So we clear this work in here. So using the cosine rule here now, we can say cos theta is equal to the square root of 17 squared, so the square root of 17 squared plus the square root of 29 squared minus 2 root 13 squared. Okay, and we divide this here by 2 times root 17 times root 29. Okay, and all we need to do here is evaluate this on our calculator and then take cos inverse of this. So here this gives us minus 3 divided by the square root of 493. So therefore, to evaluate theta here, we do cos inverse of minus 3 over the square root of 493. So in that case, what we should get here, if we do this correctly, is 97.77 degrees there. Remember, give our answer to 2 decimal places. So that gives us the solution to our example, and gives us everything we need there for using the cosine rule to find the angle between 2 vectors, and that concludes this Maths Made Easy video on vector calculations.